Hello everyone, I am Neeraj Kumar Sen, working as an assistant professor in ABES Engineering College, Ghaziabad. Our today's topic is segmented phasing and phased segmentations too. So segmented phasing. In this, the main memory is divided into variable size segments which are further divided into fixed size pages. Pages are smaller than the segments. Each segment has a page table, which means every program has multiple page tables. The logical address is represented as segment number. That is what the base address is, page number, and page offset. So segment number is what? It points to the appropriate segment number. Page number, it points to the exact page within the segment. And page offset, it is used as an offset within the page frame. So each page table contains what the various information about about every page of the segment. The segment table contains what the information about every segment. Each segment table entry points to a page table entry, and every page table entry is mapped to one of the page within the segment. Meaning what? We created a segment table which contains what the page table entries, multiple page table entries, as it is not possible to accommodate all the pages inside the segment table. So what we created, multiple page tables, as you can see, page table 1, 2, and 3, and reference of those page tables are stored inside the segment table. And on the basis of segment tables, we can access particular page table. Inside the page tables, we stored what? Page table entries, and those entries again reference with the individual segments. Means, as you can see that page table entry 1 is stored inside the segment 1. Page table entry 2 is also stored inside the segment 1, and 3 is also stored inside the segment 1. So all those pages are stored inside the segment 1. Similarly, segment 2, segment 3. So you can see that we can store number of processes or number of pages inside the segments. It is what the it is not a new technique. It is what the combination of the segmentations and phrasing. So to avoid external fragmentations, internal fragmentations, and to accommodate more number of pages inside the segment tables, so it would reduce the overhead and can accommodate many pages. So inside the main memory, we stored what? Different segments, so which can uh, be accessed as per the requirement. And the logical address is stored for the base segment address, page number, and page offset. On the basis of all those, we can access easily the segment. Now the difficult task is what? To translate a logical address to a physical address, as we are having multiple segment tables, multiple page tables, and multiple segments, one inside the other one. That how we are going to calculate. So before calculating all those things, one need to understand what is S over here. That is what the segment table. SO is what the segment offset. P is what the page number, and PO is what the page offset, and F is what the frame number is. So now considering that we are having a page table. Inside the page table, there are we are having what? The segment table. Inside the segment tables, we are having what? The page table entries. Number of page tables can be stored over here. So there is the segment limit that let's suppose 0 to 500 we can accommodate. So those many page tables are stored over here with their base addresses, means from where they are starting with. And as CPU generates what the logical address is, that is what the segment table and segment offsets collectively. So segment table is what having all the page table entries are there, and collectively it is checked with the base address. If it is lesser than the base address, then the segment offset will be further divided into the phase and phase offsets. And once it is done, so it will fetch the information from the phase table and the phase offset. So that very phase will fetch what the required frame, which resides inside the phase table, one individual phase table, and that frame will be calculated and will be provided to this very address. So that frame and phase offsets collectively we fetch the from the physical memory. And what if that phase table doesn't exist? In that very case, it will generate an invalid address. So there are some pros and cons for segmented phasing. So advantages are what it reduces memory uses, phase table size is limited by the segment size, as it cannot be larger than the segment size. Segment table has only one entry corresponding to one actual segment, and external fragmentation is not there. It simplifies memory allocations. There are a few disadvantages too. It will have internal fragmentations. Complexity level is increased as compared with the phasing. And phase tables need to be continuously stored in the memory. That is again a tedious task. To overcome this, what we use is phased segmentations. So in segmented phasing, not every process has the same number of segments as it is predefined the segment table entries. In the segmented phasing, what we use are a fixed segment size. But in reality, every process doesn't have the exact same number of segments as we are maintaining over here. And segment tables can be larger in size. So it will cause what? The external fragmentations as varying segment table sizes are there. To solve such problems, what we use is phase segmentation, which requires what the segment table to be paged. In this, what we are having what the pages are, and inside the page table, we are storing what segment table. Logical addresses generated by the CPU will now consist of what? The page number and segment number, page number 2, and the offset. So this is what we reduce the internal fragmentations. Page table, even with segmented paging, can have a lot of invalid pages too. Instead of using multi-level paging along with segmented paging, the problem of larger page table can also be solved by directly applying the multi-level paging instead of directly using of the segmented paging. As you can see, that page table for the segment table is having those many pages. Inside the page tables, what we page number, we are storing what the base address for that very page table. So inside the page table, there is some limits also. That is the limit address, and for various page tables can be stored. And those are for the reference with the different page tables. And these page tables are nothing but the segments, different segments. So as you can see that segment table divided into pages is those many pages, and further those are converted into the page table of segment. It is obvious that it will also have some advantages and disadvantages of using page segmentations. So advantages for that is no external fragmentations is there. It reduced memory requirements as number of pages limited to a segment size. Page table size is smaller. It is just like a segmented paging. Similar to segmented paging, the entire segment need not to be swapped out. It increased flexibility in memory allocation, improved protection and security. As we earlier discussed, that the paging is what the more secured. It also improves error detection and recovery, reduced overhead in memory management, improves memory utilization, and increase the program structure. And discussing about the disadvantages, so internal fragmentations still remains a problem. Hardware becomes a complex, even though the segmented paging will. Extra level of paging at first level or first stage adds to the delay in memory access, increased complexity in memory management, reduced performance, increased storage overhead, increased code size, and reduced address space. So these are what the disadvantages of page segmentations. I used those references to create this stuff. Thank you.